Hi, my name is Lindsay Calva, and I'm going to be doing a demonstration on how the addition of a non-volatile solute to pure water changes the chemistry of a solution through the observation of freezing point depression and boiling point elevation. And so what I'll be doing is I'll have equal volumes of two different solutions. One will be pure water, and then one will have a non-volatile solute, which I'm just going to use table salt, so NaCl, and I'm gonna boil both solutions and then freeze both solutions and hopefully observe how the freezing and boiling points differ in each solution. So I'm using this picture because I think it's well done, but this is actually demonstrating how the addition of a non-volatile solute to pure water changes the vapor pressure of a solution. So you'll see that the curve, the vapor pressure solution is lowered, right? And that's going to change the freezing point. You'll see freezing point depression because at 1 atm, now the temperature needed to melt the solution or freeze the solution is lower. And same here, you'll see boiling point elevation, right? Because instead of here, the temperature is now higher, which is boiling point elevation.
So here are my supplies. I have a spoon, which I'll use for mixing. I have 2 measuring cups, each with a 1 cup tick mark for my solutions. Then I have 2 extra cups for pouring extra water in, and then I have another little measuring cup. This one is 1/4 of a cup. I have a little food thermometer for measuring the boiling points. It doesn't measure freezing temperatures, so I'll improvise there. Then I have just some table salt. It's iodized salt, so there's some other stuff in there, but it's mainly just NaCl. It's the first ingredient. So I'm assuming the other stuff will just be negligible. And then a pot. And then you'll also need a stove and a readily available clean water supply. So I'm going to start by filling each of my measuring cups with my clean water supply. It's purified water. The stuff in it. I'm going to put 1 cup in each, so I'm using the same volume for each solution. And you can see right here, 1 cup in each. My larger cup will be my sodium chloride solution, so I'm just going to add the salt now. And I want it to be fairly concentrated so that you can really see a difference when adding the non-volatile solute. So I'm going to mix it until it's fully dissolved. Next, I'm going to boil my pure water on the stove. The stove is cool, the pot is cool, and I'm going to boil it at medium. All right, you can see that there. And then I have my little thermometer. I'm going to measure the boiling point of the solution, the temperature. So you can see that here. I'm measuring it. I'm wearing an oven mitt because it was hot and I was burning my hand initially. So here's that. It's about 70. Next I'm going to do my sodium chloride solution. I've let the pot cool, I left the stove top cool, but I'm doing everything in the same pot on the same part of the stove top. And I'm going to boil it at the same temperature, so you'll see me set that to medium. Hopefully I got that on camera. And then I'm going to take my thermometer and I'm going to measure the boiling point, the temperature. And you'll see that it eventually gives above 80. It got to about 90, but I took my hand off the stove because it was getting really hot and it burned my hand a little bit through the glove. So you'll see right here it's starting to get above 80, just a little bit. There you see it goes. Next, I'm going to freeze my solutions. The large cup still has the sodium chloride in it, and the other cup is just pure water. So I'm just going to freeze them in an ice bucket in my freezer. And I'm going to leave them here overnight so that they both have the same amount of time to freeze. Hopefully they'll both freeze because it's a large amount of water. Yeah, that's good. Socks and sandals check. Yeet. Quarantine. So it's next morning. I'm taking out my samples. That is the pure water. You can see it's frozen. And that is the sodium chloride solution. It's pretty frozen still. So right after taking it out, you can see it better. That's pretty well frozen. Nothing happens when I touch it. But this one, the surface breaks through really quickly, and there's a little bit of liquid underneath the surface. It didn't freeze all the way, indicating that it probably has a lower freezing point, excuse me. So you can see that better here, that it's pretty broken up really easily, whereas the other one nothing happened when I jammed my spoon into it. So I'm gonna add water here, the same amount to each one at the same temperature at the same time. And hopefully what I'm assuming to do is when I'm adding water, what's gonna happen is there's gonna be a heat exchange between the liquid water and the solid. And heat's gonna flow into the frozen sample, and there's not gonna be a temperature change because at a phase change, there's no temperature change. But I'm hoping to show which one will have a lower freezing point, because the one that is exposed to the same amount of heat but unfreezes first, it melts first, we're assuming has the lower freezing point because it needed less heat to melt. All right, and you can see that that's melted a lot more exposed to the same amount of water, whereas that one is still hard. It's literally just the water on top of this blob of ice. Yeah. So I let them sit for a little while. And you can see that one's melting quite sufficiently, whereas the other one is still just water on top of a glob of ice.